Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are on the topic number basis and this is the second video on number basis. In the previous video, we saw that in the usual operations of numbers that we perform, that is the addition, subtraction, multiplication and division of numbers that we perform, the numbers we handle are usually in base 10. But there are other bases other than base 10. In this video, we are going to see how to convert numbers from other bases to base 10. So let's pick some examples and see how this is done. We are being told to convert the following to base 10 and we have been given from I to VI. So you will take them one after the other and see how this is done. With the first example, we are being told to convert 11001 base 2 to base 10. So we are going to see how to do this. Now whenever you are given a number in a different base to convert to base 10, the first thing you need to do is to multiply each digit in the number with the base. Now this is what I mean. Multiply each digit with the number with the base. So you take the first digit or the first number here and you multiply it with the base. Then you close the bracket, you bring the addition sign. You take the next one, you multiply it with the base as you can see here. You take the next one here which is 0, you multiply it with the base which is 2 as you can see here. You take the next one again which is 0, you multiply it to the base, then you take the next one, in this case which is the last one, you multiply it with the base as you have seen here. Now after you have done with this, you have to indicate the order of the base multiplying each digit. I'm going to repeat what I said. You indicate the order of the base multiplying each digit. Now you can see from here that we have multiplied each digit with the base. Now the base multiplying each digit has an order. This is what I mean by an order. Remember from indices that we can write a number, for example, you can write 3 exponent 4. Now when you write 3 exponent 4, 3 is referred to as the base and 4 is referred to as the power or index. It's also referred to as the order. So in this case, the order of 3 is 4. The power of 3 is 4 or the index of 3 is 4. So what I mean by indicate the order of the base multiplying each digit is that the bases multiplying these digits, in this case these 2, 2, 2, 2 and 2, each one of them has an order, a power or an index. So you have to indicate it. Now this is how it's done. Beginning from the right to the left, the order or power of the first base is 0. Then the next one is 1, the next is 2, 3 and 4. So after you've multiplied each digit with the base, what you have to do is that you indicate the order of the bases multiplying each digit. So beginning from right to left, the order of the first base is 0. Then you continue 1, 2, 3, 4. So it's going to continue up to the highest order possible. So in this case, the highest order possible is 4. So you have to end at 4. So it always begins from 0 and it continues up to the highest order possible. Now you can see from here that the powers were given to the bases, not the digits. So remember that when giving the powers, give it to the base, not the digit or the number that is being multiplying it. So you continue with the simplification. So here we know that we are going to have 1 times 2 exponent 4. 2 exponent 4 is the same as 2 times 2 times 2 times 2. And we know that will give us 16. 1 times 2 exponent 3. 2 exponent 3 will give us 8. 0 times 2 exponent 2. 2 exponent 2 will give us 4. 0 times 2 exponent 1. 2 exponent 1 will give us 2. Then plus 1 times 2 exponent 0 is 1. If you watch the video on indices, you remember that any number or variable raised to the power 0 is 1. So 2 raised to the power 0 will give us 1. So we continue with the simplification. 1 times 16 will give us 16. 1 times 8 will give us 8. 0 times 4 will give us 0. 0 times 2 will give us 0. 1 times 1 will give us 1. So we have 16 plus 8 plus 0 plus 0 plus 1, and that is giving us 24. So if you convert, we can say that therefore 11001 base 2 is 25 in base 10. So in base 10, the number is 25, but if you convert it to base 2, it's 11001 base 2. So we can say therefore 11001 base 2 is equal to 25 base 10. Remember that 25 base 10 is the same as 25. You can write it without the base since it's already in base 10. Let's pick the next example. So we have 1121 base 5. So what you do from here is that first you multiply each of the digits with the base. So you multiply 1 with the base, which is 5. You multiply 2 with the base, which is 5. You multiply 2 with the base, which is 5. Then you multiply the last one, 1 with the base, which is 5. Then from here you order it. So the first one beginning from right is 0. The next one is 1. The next one is 2. Then the next is 3. So we come here, you have 1 times 5 exponent 3 is 125, plus 2 times 5 exponent 2 is 25, plus 2 times 5 exponent 1 is 5, plus 1 times 5 exponent 0 is 1. Remember that any number exponent 0 is 1. So 1 times 125 will give us 125, 2 times 25 will give us 50, 2 times 5 will give us 10, 1 times 1 will give us 1. So we add 125 to 50 to 10 to 1, and we are getting 186. So we can say that therefore 1221 base 5 will give us 186 base 10. So if you convert 1221 base 5 from base 5 to base 10, you are going to get 1860. So you see from here that it follows the same principles as we did in the first one. Let's take the next example. We have T181 base 12. Remember that in the first video we said when you write T in base 12, the T stands for 10. So from here it follows the same principle. Multiply each digit with the base. So we multiply T with the base, which is 12, then plus 1 with the base, which is 12, 8 with 12, then 1 with 12. Then you order. Remember that when you are ordering, you begin from right to left. So 0, 1, 2, then 3. So here the highest order possible is 3. So you end at 3. Now we continue. We know that T is the same as 10 in base 12. So T will give us 10 times 12 exponent 3 will give us 1728. You can do this on a calculator and you see that you are going to get 1728. Then plus 1 times 12 squared will give us 144, plus 8 times 12 exponent 1 will give us 12. Any number exponent 1 is the same number. Plus 1 times 12 exponent 0 will give us 1. Any number exponent 0 is 1. So you are going to have 10 times 1728. That will give us 17280, plus 1 times 144 will give us 144, plus 8 times 12 will give us 96, plus 1 times 1, which will give us 1. So we add all this and we are getting 17521. So what it means is that if you convert T181 base 12 to base 10, you are going to have 17521 base 10. Let's pick the next example. We have 1441 base 6, and we are supposed to convert this to base 10. So once again, you multiply each digit with the base. So you multiply 1 with 6, you multiply 4 with 6, you multiply 4 again with 6, then you multiply 1 with 6 as we see here. Then you order it beginning from right to left. So 0, 1, 2, 3. From here you continue with the simplification. So we have 1 times 6 exponent 3 is 216, plus 4 times 6 exponent 2 is 36, plus 4 times 6 exponent 1 is 6, plus 1 times 6 exponent 0 is 1. Any number raised to the power 0 is 1. So you are going to have 1 times 216 to give us 216, plus 4 times 36 to give us 144, plus 4 times 6 will give us 24, plus 1 times 1 will give us 1. So we have You add all this and you are going to get 135. So it means that if you convert 1441 base 6 to base 10, you are going to have 385 base 10. Now let's pick another example. In this example, we can see that we have a decimal point in it. So the procedure will be the same, just a slight difference. So you are going to see how to do that. Once again, you multiply every single digit in here with the base. So you multiply 1 by the base, so 1 times 2, then 1 times 2, 1 times 2 as we see here, 0 times 2, then 1 times 2 here. Now, because we have a decimal point here, you first have to order for the whole number part, then we order for the decimal part. So ordering for the whole number part, we know that the whole number part ends here, then this part is the decimal part. The decimal part are the 3 digits at the end, then the whole number part are the 2 digits at the beginning. So first do for the whole number part. So ordering for the whole number part, we know that it's going to be 0, 1. So this is the whole number part. We have ordered for the whole number part here. Then from here you order for the decimal part. Now when you are ordering for the decimal part, you can see for the whole number part, we begin from right to left. So right 0, then we go here 1. When you are ordering for the decimal part, you begin from left to right, and the first one is going to be -1, then the next one is going to be -2, then the next one is going to be -3. So it will continue up to the highest order or the lowest order possible. So whenever you have a decimal part, don't forget that it follows the same principle. Multiply each digit with the base. Then you first order for the whole number part. So we are ordering for the whole number part. That will give us 0 and 1. Then you order for the decimal part. For the decimal part, you begin from left to right, and the first one is -1. The next one will be -2. Then the one that follows will be -3. From here, you continue with your simplification. You know that 1 times 2 exponent 1 will give us 2, plus 1 times 2 exponent 0 is 1, plus 1 times 2 exponent -1 is 0.5, plus 0 times 2 exponent -2 is 0.25, plus 1 times 2 exponent -3 is 0.125. So 1 times 2 will give us 2, 1 times 1 will give us 1, 1 times 0.5 will give us 0.5, 0 times 0.25 will give us 0, 1 times 0.125 will give us 0.125. So we add everything here, we are getting 3.625. So we can say that if you convert 1.101 base 2 to base 10, you get 3.625. Let's take another example. We have 133.02 base 4. So all that you need to do is to multiply each digit with the base. So you multiply 1 with the base, you multiply 3 with the base, you multiply 3 with the base again, you multiply 0 with the base, then you multiply 2 with the base. Now since we have a decimal point here, you have to order for the whole number part, then you order for the decimal part. You know that the whole number part will end here. The decimal part are the last 2 digits. So order for the whole number part. So we have 0, 1, 2. Then from here you order for the decimal part. The first one will be -1, then the next one will be -2. Then you continue with the simplification. So we have 1 times 2 exponent 4, which is 16, plus 3 times 4 exponent 1, which is 4, plus 3 times 4 exponent 0, which is 1, plus 0 times 4 exponent -1 give us 0.25, plus 2 times 4 exponent -2 give us 0.0625. 1 times 16 is 16, 3 times 4 is 12, 3 times 1 is 3, 0 times 0.25 will give us 0, plus 2 times 0.0625 will give us 0.125. We add everything here and we are getting 31.125. So it means that if you convert 133.02 base 4 to base 10, we are going to have 31.125. Thank you for watching this video. Pick more examples on how to convert numbers from other bases to base 10 and use the same principles that we have done in this video. Try your hands on these examples and you'll be conversant with them. See you in the next video where we will learn how to convert numbers from base 10 to other bases. Bye bye.